had pointed out. It's not that complicated. There's a Stegosaurus, there's a T-Rex, and then that's a Velociraptor.
Alrighty guys, we are already on week 5. I can't believe so many weeks have gone by.
It's been 84 years.
Our title for today is What Do Similar Shapes Tell Us? Graphic artists often need to be able to shrink and enlarge their designs to scale. They may need to make a shape larger to use for a sign, or they may need to make a shape smaller to use for a bumper sticker. They have to be sure that the shapes look the same no matter what size they need to make the design. How do artists know what the side length of a new similar shape should be? Today you will be exploring how to get the scale factor just by looking at 2 corresponding sides between 2 shapes. Our big question of the day is, how do we find the scale factor, or what we call the multiplier, from one shape to another? And I highlighted multiplier because it's important that we remember when we're finding scale factor, you are not dividing, you are not adding or subtracting. You have to multiply. Okay, that's very important. I want you to remember that. Alright, so our job today is going to be to find the scale factor between each pair of similar shapes. That is, what are the sides of each original shape multiplied by to get the new shape? So again, we're going to have scale factor right here, and then I'm going to just highlight multiplied so that we remember that's what we're doing. What is the scale factor that I need to go from the original shape to go to the new shape, aka what do I have to multiply by? And when we look at our 2 shapes, the first thing that we want to do is identify corresponding side lengths. For example, this right here, this bottom piece that's 12 inches, its corresponding side length would also be the base of the new shape. Okay, so those 2 sides are corresponding, meaning they're matching. And then when we go over here, this piece of 6 inches right here is corresponding to this piece. All right, and that's really easy for us to tell, not just because it's on the right, but because it is on the opposite side of this right angle that you see right there. And now what we're going to do is we want to find the scale factor. So we're going to show our work right here. I'm going to write original. Okay, and then I'm going to write new. And all of our data from the original shape is going to be here, and all of our data from the new shape is going to be here. Remember, we're trying to find a number that they can multiply by in order to get from one to the other. So we're going to start with this corresponding length in blue, and I'm going to write 12 inches. And for our new shape, you see here, it's 6 inches. And then for our green side lengths, our original is 6 inches. And our new shape is 3 inches. All right, and you always go from the original to the new shape. If you don't, your scale factor could be off. So what we're going to do now is we're going to think. We have 12 and 6. We want to go from 12 to 6, and we want to multiply by something. I have had a lot of students go, oh, you just chop it in half. You chop the 12 in half, and you get 6. So you divide by 2. However, if you remember, we are multiplying. So if you divide 12 by 2, you're correct. You get 6 inches. And then we also see that if you divide 6 by 2, you'll get 3 inches. But we can't divide, so how do we translate that into multiplication? Well, if you times by 0.5 or a half, it's the same as dividing by 2. So if we times 6 by 1/2, we're going to get 3. And if we times 12 by 1/2, we're going to get 6. So then right down here, you're just going to write scale factor. And underneath, you're going to write 0.5. You can also write 1/2 if you'd like as a fraction. You do not have to, but you can if you'd like to. All right, here we have a new shape, but I want to do what we did for the last problem. We need to go from our original to our new shape. And the question that it's asking us is, it says, what is the scale factor, aka what do we have to multiply by? So we're going to go from our original shape to our new. So I'm going to write just right here. Original. And then I'm going to write new. Here we don't have as many measurements as the last problem, but we do know that this side is a corresponding or matching side length to this side. So we are going from 4 inches in the original to 5 inches in the new shape. And we know that we have to multiply by something in order to get from 4 to 5. And I'm going to share with you guys just a quick trick for you so that it will make this process a little bit easier. If we are going from 4 to 5 and we have to multiply by something, would you agree that you can then go from this to this by dividing by that same number? Right? Because division and multiplication are reciprocal, which means that if we do 4 times 2 equals 8, that means 8 divided by 2 would be 4. So you can go forwards and backwards with it. 4 to 5 seems like kind of a messy guess and check multiplication problem. So instead, I'm going to do this. 5 divided by 4, and I'm going to get this number. 5 divided by 4 equals 1.25. So if you're ever stuck, you take the last number, so the new number, and you divide it by the original number. And you will then get your scale factor. Okay, it's as easy as that. Then I'm going to write right here times 1.25. And if you do that in your calculator, you will find that that is correct. And then I'm going to have you write somewhere on your paper so that I know what the answer is and so that you keep track of it. Scale factor equals 1.25. And there's your answer. All right, I'm going to introduce the next problem, but I'm also going to let you know that this problem has a series of analysis questions on it. So I want to make sure that you are paying attention so that you know how to answer the analysis questions. A study team was working together to find the scale factor for the two similar triangles below. Use these two triangles to answer the questions on the next page. Hint: when thinking about the problem, it may help to look at the numbers you see in the ratios and find them on the triangle so you know which lengths are being compared. And I'll show you what I mean by that. Alrighty, so the last hint told you to look at the fractions that you see, the ratios that you see down here, as values on these triangles. And what that means is when you see 14 over 4, you know that it's 14 over 4. When you see 28 over 8, you know that it's this side length and this side length. And when you see 21 over 6, that's this side length and this side length. And as we're looking at these highlighted portions, we can tell right away all of these are corresponding, right? The base and the base, the top right and the top right, the small, shorter left side and the small, shorter left side. They all match up. And I want you to also think about our last problem and how we found the scale factor. For our last problem, the way that we found our scale factor was similar to the way that we are finding the scale factor in this analysis question, because we took the new and we put it over the original. And what I mean by that is right here, 5 divided by 4, we took the new length and we divided it by the old length. Right? And we found our scale factor. So now that we're back down here, we see again we have new side length, this 14 over original, new side length, the 28 over original 8, and new side length 21 over old side length 6. So I want you to consider this as you guys are going through and answering your analysis questions. Analysis questions 8. What did the students do differently when finding their ratios? Do the triangles have more than one scale factor? If not, how are they the same? And I'll give you the same hint that I gave you before. Treat each fraction as a division sentence and find out what it equals. For example, 12 over 4 really means 12 divided by 4, which equals 3. So 3 would be the scale factor if you were looking at this ratio. We just did that in the last problem. In the last question, What is the scale factor for going from the original triangle to the new triangle, and how do you know? I gave you a space to write scale factor. I also gave you this sentence frame. I know this because I want you to be able to prove it. And for each of these other analysis questions, I want to make sure that you guys are providing ample detail so that I'm able to understand everything that you guys are thinking as you answer these questions. So please use complete sentences and make sure to put in as much detail as you can. Alrighty, moving on, we've got some more triangles to look at. We are starting 6-89, which will prepare you for answering our next set of analysis questions in the next problem. Look at the triangles below and solve for x and y using the scale factor that you are given. Okay, so instead of finding our scale factor for this one, guys, it tells us that in order to go from shape G to shape H, you need to multiply by the scale factor of 1.25. So now instead of giving us both numbers and saying, hey, find the scale factor, they only give us one number and the scale factor and say, hey, find the missing side length. A hint, this means that each G length, so this is G, needs to be multiplied by 1.25, our scale factor, in order to find each corresponding or matching H length over here. So just like we have done in the past, we are going to highlight our corresponding sides. This 4 inches right here has a corresponding side over here for the 5 inches. This side right here has a corresponding side right here. And lastly, this side, this base, corresponds with the base over here. Alright, now, like I said before, whenever we are doing scale factor problems, we are always going from the original to the new shape. In this case, this is going to be the original, and this is going to be the new. So I'm still going to write it out. Original. And then in parentheses, I'm just going to write G, because we know that the G shape is our original. It tells us in the problem above. And new. And I'm going to write H. Now we are going to try to find X. All right? And X is right here. X is in our new shape. So I'm just going to leave a blank because we don't know what X means yet. And we are going to have to correspond it with 6 inches. So over here, I'm going to write 6 inches. So that's our original length. Make that green. And now we know our scale factor because the problem told us. So I'm going to draw an arrow and just say times 1.25. And then you very easily can find your answer. 6 times 1.25 equals 7.5 inches, which means that X equals 7.5 inches. And because this is a value of measurement and we are defining it by a variable, I always like to box it. And then I actually like to go up here and write 7.5 inches just for my reference. Now our next one, we're going to do the same thing. We have to start with the original over here. Original, which is G. And then we'll put our new measurements over here, which is H. And I'm going to have to drag this down a little bit, guys. I apologize. Our new measurement is going to be 10 inches. And our old measurement, we're not sure what it is quite yet. So we're going to put a blank here, just like we did in the last one. And the one thing that we do know is that our scale factor, if we go from old to new, is going to be times 1.25. But what if we want to actually go this way? We want to go new to old. If this is multiplication, then this very easily just becomes division to undo it. So if we go this way, we're multiplying. If we go this way, we have to divide. So we're actually going to divide by 1.25. And 10 divided by 1.25 gives us a value of 8 inches. So then I'm going to write y, because that's the variable we were looking for up here, equals 1.25, equals 8 inches. And don't forget to put your measurement value on here, because if you just write 8, I don't know what you mean. It could mean 8 cats, 8 pieces of toast, could mean 8 cars. If you don't specify this last part, I have no idea what measurement you're using. Alrighty, moving on to your analysis questions. For 6-90, which is this problem right here that you see, for the parts of similar shapes below, find the lengths of the missing sides. To do this, you must first find the scale factor. You can decide which shape you want to be the original and which shape you want to be the new. What I would recommend doing is writing original or new in the shape so you know which way you're going. Because you always, in order to find the scale factor, have to go original to new. Always, always, always. I'm going to move this over so you guys can see that a little bit. All right, and one thing that is going to be important here is finding the correct corresponding side. So I'm actually going to highlight them for you. This side here corresponds with this side. This side corresponds with this side. And this side corresponds with this side. Which means that, let's say you made this the original, you would have to go, your original value would be 33, and you'd put it here, and your new value would be 11, and you'd put it here, and you would find out what you needed to do in order to go from 33 to 11, what you would multiply by. Or you could do the opposite if you wanted. This could be your original, this could be your new shape. You have to make sure to label it though, so let me know when you're doing your analysis question. I'll be able to tell by the scale factor either way if you did it correctly, but make sure to label it for yourself. For this one, you have 3 values that you need to find. The last one you only had 2. This one, this side length corresponds with this side length. This side length corresponds with this side length. This one corresponds with that. This one corresponds with that one. And running out of highlighters here. And this one corresponds with that one. Okay, so it's important that you remember you're going from the original shape to the new shape, finding out what the scale factor is. And once you do that, for example, If you found the scale factor to go from 33 to 11, you would just look at this number and multiply it by the scale factor, and you'd have x. And then you would go here and you would say, okay, that's my new value. I'm going to have to go backwards. I'm going to have to divide by the scale factor, and you would get this number. Okay, so just make sure that you're telling me what x and y, and for this one, there's an x, a y, and a z. Make sure you're telling me what those equal. And if you have questions, you can email or text or call. Feel free to reach out to me. But I will let you know that I'm going to ask you to watch this video before you ask me to give you any answers or any help on this. Alrighty, this last problem is kind of a fun one. It asks us to look at the figure below and use it to answer the following questions. Our first question says, find the area of the shape. A hint, this is pretty easy. Count up how many squares it fills up. So for this, I want you to remember that whenever you're finding area, you have to give me units squared, because it's a area, it's not just a specific length. It takes up a lot of space. So when we look at this shape, we can very easily just count 1, 2, 3, 4, 5, 6 and a half, right? Because it takes up half of that. So we're just going to say that the area equals 6.5 units squared. And that's going to be your answer. This first question is pretty easy peasy. All right. But our next one is a little bit more complicated. It says, now enlarge the shape by a scale factor of 2. Draw the new shape and find its area. So it says to enlarge the shape, which we also know means to dilate the shape, by a scale factor of 2. Usually when we dilate something, we're on a graph, and it gives us plot points that we can follow. But if you look here, there's not really any plot points to follow, and we're not actually going to put them on the graph. What I'm going to have us do is you can kind of decide where you would like to put the shape. I will give you that opportunity. What I am going to do is I'm just going to start counting side lengths and then drawing its corresponding side length. For instance, this side length is 3, right? 1, 2, 3 squares. So I'm going to make one that's 6 squares. 1, 2, we'll start here. 1, 2, 3, 4, 5, 6. Okay, here's my base. Okay. So that corresponds with that side length. Now let's look at the next side length. Let's do this side length right here. Okay, that's 2 tall. So we're going to make this next side length 4 tall because we're doubling. We're multiplying by 2. It's a scale factor of 2. Okay. Then our next one is also going to be 2, but it's a horizontal line to the left. So we're going to go, if this is 2, we're going to make one 4 long. So we're going to go like this. One, 2, 3, 4. Let's see, what colors have we not used yet? Okay. This is a diagonal line. And actually, we'll switch that up because we can't really see that very well. Let's do green instead. Okay, this is going to be our green line. And it's it's 1 straight through a square. So we're going to go from this point that we had the pink line stop at, and we're going to go through not 1, but 2. Those lines. And then our last side length here we'll do in purple, and you can see that it's 1, 2, 3 tall. So we're going to do this one 6 tall, because we're doubling, remember. 1, 2, 3. 1, 2, 3. Okay. And actually what we're going to do so that we are able to see the shape is I'm just very quickly, we'll do this. I'm going to take a color that we have not used yet. We'll do a yellow highlighter. And we're just going to color this in so that we can see all of the squares that we took up. Okay, so I'm at 1.5, and this is another half, so now I'm at 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26, which means that our area for the new shape, this one that's enlarged by a scale factor of 2, equals 26 units squared. And what I want you guys to understand from this problem, I know that some of you are like, why do we do this? It doesn't really relate. What I want you to understand is that we doubled the shape here by looking at corresponding side lengths, but the area more than doubled. So if we just doubled 6.5, you might think that the area was just 13. But in reality, when you dilate the shape and you make each side length 2 times bigger, your area is going to come out much larger than just double the original area.